In this section, we will be introduced to factoring. More specifically, we will talk about the greatest common factor. The greatest common factor of a list of algebraic expressions is the largest expression, thus the word greatest, that divides evenly. Divides means that this expression will be a factor that divides evenly into all the expressions, thus common. So this is the greatest, the largest expression that divides evenly. Divides evenly would mean that this expression is a factor into all the expressions, which means it is common to all the expressions, the greatest common factor. Factor out the GCF, or the greatest common factor, of the expression 4x squared minus 10x plus 24. First, let's list the GCF. Let's look at the 4, 10, and 24. We need to find which number divides evenly into 4, 10, and 24, and is the largest number to do so. The largest number that can divide 4, 10, and 24 is 2. Now with the x's, we have an x squared in the first expression and x in the second expression. However, the 24 does not contain an x. Therefore, the x will not be a common factor since it does not divide into all the expressions. So our greatest common factor will simply be 2. To factor out the greatest common factor, write the greatest common factor outside the parentheses. To determine what's inside the parentheses, we will divide each term by the greatest common factor. Since the greatest common factor is the largest expression that divides evenly into all the expressions, we will divide each expression by 2. So 4x squared divided by 2, 4 divided by 2 is 2, the x squared remains as x squared. Negative 10 divided by 2 is negative 5, the x remains as x, and 24 divided by 2 is 12. Four x squared minus 10x plus 24 is equivalent to 2 times 2x squared minus 5x plus 12. Let's check to make sure we did this correctly. If we distribute, 2 times 2x squared is 4x squared. 2 times negative 5x is negative 10x. 2 times 12 is 24. So we did this correctly. In the next example, factor out the GCF of the expression 12x to the 4th y to the 3rd minus 16x to the 7th y to the 5th plus 8x to the 5th y to the 4th. First, let's list the GCF. The GCF is the greatest common factor, in other words, the largest expression that divides evenly into all three of these expressions. So between 12, 16, and 8, the largest number that can divide 12, 16, and 8 is 4. Now with the x to the 4th, we have 4 x's. With the x to the 7th, we have 7 x's. And with the x to the 5th, we have 5 x's. The most number of x's we can take out of each expression is 4, since the first expression only has 4 x's. We can take out 4 x's from the first, from the second, and from the third. In other words, we can divide each of these terms by x to the 4th. And that is the largest expression that we can divide by, since the first expression only has an x to the 4th. Now with the y's, we have 3 y's. Here we have 5 y's. Here we have 4 y's. We have to determine what is the most number of y's we can take out of each of these expressions. The most number we can take out is 3, since the first expression only has 3 y's. So we can take out 3 from each expression, which means that our GCF is going to be 4x to the 4th, y to the 3rd. So let's write the GCF, 4x to the 4th, y to the 3rd, and inside the parentheses, we determine what is left over. So to determine what's left over in the parentheses, we will divide each of these expressions by the GCF, which is 4x to the 4th, y to the 3rd. 4x to the 4th, y to the 3rd, divided by 4x to the 4th, y to the 3rd. 12 divided by 4 is 3. X to the 4th divided by x to the 4th is 1. Y to the 3rd divided by y to the 3rd is also 1. Negative 16 divided by 4 is 4. X to the 7th over x to the 4th, 7 minus 4 is x cubed. Y to the 5th over y to the 3rd, 5 minus 3 is y squared. Here we got 8 divided by 4, which is 2. X to the 5th over x to the 4th, which is x. Y to the 4th over y to the 3rd, which is y. to check if this is correct, we can distribute the 4x to the fourth y cubed to the parentheses, and we should get back our original expression. Now, it might be kind of confusing because we're looking for the greatest common factor, yet with the x's we're looking for the lowest power. And that's because if we picked a power higher than 4, x to the fifth would not divide into x to the fourth. So even though it is the greatest common factor, with exponents we're limited by the lowest power, like with x to the fourth and y to the third. Here's another example. Factor out the greatest common factor. The factors of the first expression are 3x and x minus 5. The factors of the second expression are 4 and x minus 5. Notice they both have a common factor of x minus 5. So the greatest common factor will simply be x minus 5. Since that is the greatest common factor, we will write x minus 5 outside the parentheses. Inside the parentheses, we will divide both of these expressions by x minus 5 to determine what's left over inside. The x minus 5's cross cancel, we're left with 3x. The x minus 5's cross cancel, we're left with the minus 4. So our expression is x minus 5 times the quantity 3x minus 4.